Neural communication is complicated, so I'll explain it using an analogy we can all relate to: hunger. Alright, before we begin, let's brush up on some vocabulary. A neuron consists of a cell body, which houses a nucleus that controls the major functions of the cell, axons, which send electrical signals and neurotransmitters, and dendrites, which receive those neurotransmitters. The resting potential is the state of a neuron at rest. Potential is another way for saying voltage. This is me, for example, when I'm not hungry. That's my neutral state of being. The threshold of excitation is the voltage required to initiate an action potential or cause a reaction, right? This is similar to how hunger will initiate my desire to go to the fridge and get a cheese stick. I need to be hungry enough to stop what I'm doing and get up to do something, to act. The action potential is when a neuron fires off an impulse to communicate with neighboring neurons. The conditions have been satisfied and the process has been initiated. The signal starts to move down the axon. This is me getting up and going to my fridge to grab a cheese stick. There's a little rule called the all or none rule, or none law, that states there is no variation in the intensity of an action potential. Is either a response to a stimulus or there's no response. This is similar to how I can't have a part of a cheese stick. They're prepackaged, so I can either grab a whole cheese stick or not have a cheese stick at all. So if a neuron does not reach a state that satisfies the threshold of excitation, there will be no response. Alright, neurotransmitters. They're released to neighboring neurons across the synaptic cleft and lock into them. This causes the next neuron to react. In this case, releasing the neurotransmitters is me taking the cheese stick out of the plastic and eating it. The communication between neurons, or between my hunger and the need to eat, has been completed, in which is followed by a refractory period where no or fewer reactions to stimulus occur. The neuron is no longer hungry. I hope this little video helped you to understand neural communications.